Next module that we're doing, which is the energy module. The energy, where are you, energy? Okay, energy, there we go. Okay, so we were energy part 1, so now we need to do energy part 2. The way that energy works, remember, is it transfers from hot to cold. It's usually how it works. Okay, I do not have part 2 here, but I'm thinking I can get this one in there if this one opens. We'll see. We shall see if that works like I did last time. Nope, 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 it's not working. It is not allowing. Maybe if I do that, then maybe now. Now it'll do it. Okay, let's see. There it goes. Okay, now I figured out how to do this thing. All right, let's go. All right, for this particular part, we are going to look at how some of it is stoichiometry of reactions, and some of it is what is known as Hess's law. Hess's law is basically all kind of like what we did with redox, except in this case, we are looking at the reactions and their direction and their magnitude. So it's kind of very much the same, but with energy rather than electrons. All right, so you're going from a particular set of reactants to products, and there's a change, which is known as an enthalpy. So it's if you go in one step or in a series of steps, it's going to be the final product would have spent just as much energy to get to, or would have absorbed just as much energy to get to. All right. So this is what we want to look at. All right. So in order to do this, we have that Hess's law says the reaction can be carried out in 2 distinct steps with the enthalpy changes that are designed as delta H2 and delta H3. Okay. So in this case, you have that N2 and O2 are going to be 2 NO, and that's going to give you 68 kilojoules. So if you do this in 2 steps, the other reaction is going to be one that absorbs energy, right? And the other one's releases. So that's the point on here, that you are going to have 2 steps, not necessarily organized, but the final reaction is going to be the sum of all of those steps. Okay, so let's see one. Okay, so if a reaction is reversed, then the sign of delta H is also reversed. Got that? So if you have a different reaction, then you have to flip it. And that reaction is going to end up being negative. If the magnitude of delta H is directly proportional to those quantities of reactants and products, then the coefficient should be able to balance all of that too. Okay, so let's look at in another reaction, like right here, NH3, so that's ammonia, right? It's changing into nitrogen and hydrogen gas. Now, you really cannot do 3 halves and one half, so you need to be able to figure out what that's going to look like. All right, if you multiply everybody by 2, then that's what you would end up with. Now, first thing that you're going to do is you're going to have the reactions that are those 2 reactions that are going to end up in this reaction. So you have to figure out what the amount of the delta H is going to be based on this. Okay, you notice that the products are reversed on this one. So this is going to be a positive reaction, right? So if you flip it, that reaction is going to end up being so you're going to have the water on the reactant side and the hydrogen and the oxygen on the product side. So that's what flipping means. You're going to reverse it, right? You're going to reverse the reaction. And that means the products are going to become the reactants and the reactants are going to become the products. Therefore, it's going to be a positive sign. So that negative sign, you reverse it, it becomes positive. When you add those two together, you still got to multiply something though. So let's look at that. Excuse me, I yawned. All right, let's look at that. Okay. So like I was saying, we're going to have to rewrite this reaction backwards. So the H2O is going to go here, right? And then this is going to be 2, and this is already balanced. So 2H2 plus O2. And that's going to make this delta H no longer this, but it's going to be positive 484. Okay, kilojoules. All right, now this one on the top needs to be multiplied, doesn't it? Because you can't have 1/3. So if we multiply everybody times 2, right? So that means this is 2, this is 2, and this is 2, right? So 2 times 3, and so that ends up being 2 NH3, sorry, plus, not plus, yields. 2 over 2 is 1, so it's just 1 and 2. And then plus 3 times 2 is 6 over 2 is 3, so 3H2. All right, so we multiplied this times 2, didn't we? That's going to give us, yeah, this is what I was telling you, 92 kilojoules. We didn't reverse it, we just multiply it. So when you add it all up to get this reaction right here, right, you have to add both of those reactions, which would give you 2. Oh, and we did reverse it. Never mind. We did reverse it on also. Okay, so we reverse this reaction. So it's going to be negative 92, right? So when we, oops, so let me rewrite this because I screwed up here. And that needs to be reversed. Not only duplicated, but reversed. So you've got 2 and 2 plus, oh, sorry, not 2 and 2, 1 and 2, just 1. 1 and 2 plus 3O2. Come on. 3O2 yields NH3. Right? That's how it went. All right, so we multiplied it, but we also reversed it. So we multiplied it times 2, we got that part, but we also reversed it, so we need a negative. So when we add both of these, that reaction should be equal to that. Now, looking at our yeah, we are definitely going to need to multiply it times 2, not times 2, times 4, it looks like. Well, once you added the whole thing, then you need to let's see, you've got to think about it while you've got it here. So this into, that made it 2. Yeah, that made this 2. Yep, sorry. And then now you need to multiply it times 2 again, because you want to have the same amount of oxygen. So you got to look at that. And on both sides, the oxygens, you want to get rid of them. Actually, you end up, yeah, you end up subtracting them. So yeah, you do need this. Okay, we reversed the wrong one. No, we didn't. We reversed both. They both had to be reversed. That's weird. I know I'm not used to having both of them reversed. But once you reverse them, and anything that you do to the equation, you have to do the same thing to the delta H. So if you reverse it, delta H has to be negative. If you multiply it times 2, then you have to multiply delta H times 2, which is what we did here. but I'm still not balanced. So this is what I'm trying to do here. I'm trying to figure out how to balance this. We are going to need 202s over here. Yeah, that's right. These are balanced. Why is the N2 doubled? No, oh, because of the H's. That's what it is. Yeah. Okay, so once we get to where we are, and these both are balanced. Both of the separate ones are balanced. But once we put them together, that's the thing. Once we put it together, we got to do N2 plus, we had 302, right? Yields NH3, and it's two of them, two NH3s plus two H2Os plus O2. Okay, so that's your reaction, but as you can see, it is not necessarily balanced. That's an NH3, sorry, that's a 3, you can barely see that. All right, so you've got no balance on the other side. There's no water. Did I forget the water? Yeah, I did forget the water. It's, like I said, sometimes it's kind of, come here, eraser. I need to put the water in here, so that's why I'm making it a little more calm. Okay, 2H2O plus. There we go. So that's your reaction, right? Now we get rid of the ones that are in common, and that would be the waters. But in this case, they're not balanced, and that's what we need to look at. We need to balance those oxygens. We need one more on this side. So why on earth do we have? Did I forget to multiply? No, I didn't. No, it's all twos. Okay. Something's weird. Hold on, let me start it over again because something's weird here that I didn't like. Okay, one more time. Are these balanced? Yes, that bottom one is balanced. There's no doubt about it, right? The top one is not balanced. And they're saying 4. Why 4? Oh, I see. Because if you put 2 there, no, that becomes a 3. No, that's 6. It's like weird. I don't understand why they're using this bigger number. Why are they using the 4? It's because of the oxygen. The oxygen is not balanced. Yeah. But there's no oxygen on the other side. Yep. So when you multiply and you reverse. So that would end up being N2 plus H2 yields NH3. And that's your reversing. Now, you know, they have it in 3/3 and 3/2 and all that, which is weird. But if you want to get rid of the halves, you just multiply everything times 2, and you end up with 1 there and 3, sorry, 2 times all of that. So 2 times that. There we go. That's no, but that's a half. So they're saying this is 4, which it would be 4. And if this is 2, there we go. Okay, that would no, that wouldn't be 2, that'd be 3, because it's 4 times 3 is 12. So that has to be 6. Oops, come on. Eraser didn't want to come up. Yeah, that would be 6 right there. Okay, so what we did to that one is we reversed it and we multiplied it times 4. So reversing it means that delta H is now, this delta H is now, let's see, clear, 46 times 4. it's 184. So, but it's negative 184 because we reversed it and we multiplied it times 4, right? And reverse. Okay, the bottom one, what do we have to do to you? We have to multiply it times 3. It looks like. And reversed it too. So we need to reverse this one. So that makes it 484. But then we also multiplied it because I'm looking at this and we multiplied it times 3. So this one we multiplied times 3 and this one we multiplied times 4, right? That's how it went. And we reversed it too. So reverse. So reverse that one. That would be 6H2O, right? Plus yields 2 times 3 is 6 H2s plus 3 O2s. There we go. That's how it works. All right, now we have it. Now, what we need to do is multiply the delta H, which is negative 484, and we reverse it so it's positive 484 times 3. There we go. I knew there was something weird here. Okay, and that is 1452. All right. And that's kilojoules. And we reversed it, right? Because it was negative, now it's positive. So now we add both of those and we add both of these reactions. And when we look at it, you can see that the 6H2s are going to cancel. You see that? The 4NH3s, they did not. The waters, however, nope, they did not either. The N2s, are they going to cancel? Nope, no N2s. Okay, so we need to keep the N2, right, on this side, right? See, that's right here. And we also keep the 6H2, which is also right here. And then on the other side, we get to keep the 3O2, which is right here. And we get to keep the 4NH3. That's all we keep, which is right there. And there you go. Now you have the whole thing. And when you add it together, which was 1452 minus, right? Because in this case it's plus negative 184. That gives me 12. So delta H for this reaction is 1268 kilojoules. And that's how you figure it out. This always is a very complicated thing, but basically that's how it is. So did you see how we did it? You can look at the two half reactions that they give you, right? The two separate reactions, the half reaction, they're full reactions. The full reactions that they gave you, you have to rebalance them based on what you have on the bottom and what you have on the top. And after that, then you have the answer, okay? So let's clear all of that and let's look at it. Our next one is this one right here. Sorry, I had to start over again because it's hard to write it on this. So it said work backward from the required reaction. See, so that's what I did. I looked at the bottom reaction right here, right? And so that the products right here, this oops, sorry. I need my draw. I need this reaction, and I saw that this was over here. You see that? So we needed to fix it. We needed to flip it. And then we noticed that it had a 2. So I multiplied it times 2. But then that's where it got kind of complicated to me. Because it says 2 and 2, but then it says 4 NH3s. And that I did not agree with. But I guess it does. It does. Once you look at it, yes, it is. It is 4 NH3s. And then the H2 goes away with this H2, so you have to just balance those two. In this case, it would have been 2 H2s, which would have been 6. which means you have to do a multiplication on that one. And notice the water is on this side, so they both need to be flipped, right? So that's your first one. And then based on the magnitudes of those down here, you need to make sure that you multiply those by the right numbers. And that's all there is to it. Okay, so clear all these drawings and let's go back. All right, so that's the strategy. And make sure that you might want to write this strategy down or take a picture of it or whatever, but there it is. Work backwards from the required reaction, so the final reaction, using the reactants and products to decide how to manipulate the other given reactions at your disposal. So reverse any reactions as needed to give the reactants and products in the right spot, right? And multiply them to give the correct coefficients. So what you do to the reaction, you also do to the delta H. Got that? All right, let's do one more. All right, now look here. See, they're telling you what we did. Reverse the two reactions, so we did that because they're desired reactions down here. So that's the first thing to do. We reverse them, so it looks like this. And then you need to multiply them. Oops, sorry. Then you need to multiply them by the correct numbers. And the one that we needed, because it was 4, because see, that's what I was like, why is it? Yeah, but it's 4. It's 4 instead of 2. So you do need 2 here because of that. All right, because of the hydrogen. Yeah. So the hydrogens can't be a 3 if there's only 3 here. So that's where I screwed up. Yeah, you do need a 4. So everything is multiplied by 4 on the top one, and everything is multiplied by 3 on the bottom one. When you reverse the reactions though, right, you changed the direction, therefore you changed the sign. All right, and there you go. See, that is exactly what I got, right? 1268 kilojoules. All right, so let's do another one with the steps in mind. Okay, even though they're here, let's just do the right steps. Okay, so it says delta H for this reaction, given that this is our target. Okay, look at the SO2, it's in the wrong spot. So we know that this right here has to be reversed. We know that first thing. All right, so let's rewrite I'm gonna rewrite the reactions because there's not enough room up here, so I'm gonna write them down here. Okay, so we're gonna rewrite SO2 yields S plus O2, right? That's the reversing. So now this delta H is positive. Just remember that, reversed, so positive. In the O2 is in the right spot, right? So we know that's right. And they're doing the half thing, which I do not like, but they're also not balanced. So we're going to look at the 2S right here, plus 3O2 on this side, and it's going to yield SO2, 3 SO3s, right? Okay, so for this one, what we're going to need to do is we're going to need to balance the reactions. The top one's balanced, no doubt about it, right? The bottom one is also balanced. Oh, I put 3. Why did I put 3? I meant to put 2 right here. I put 3. Okay. Okay. Now, what we need now is to figure out if we need to manipulate the top reaction. We do, because we have 2 S's, so we need to multiply all of this times 2, don't we? Which would end up, so this one is going to be reversed and multiplied times 2. So this is negative, it's positive 297 now, right? Because we multiply now times 2. That's what that's going to be, okay? And the bottom one doesn't look like we have to do anything to it. Well, actually we do, because if you notice the O2 is not going to cancel like this, because we're going to end up with two O2s. So what we need is a 6 on the top and a a 6 on the top and a 3 on the bottom. So we need to multiply this one times 3. We don't reverse it though. And we multiply this one times 6, not times 2 like I had said originally. Well, you have to look at it, and then when you see the reaction, see this is going to end up with 6 O2s here, right? And you're going to have 6 S's plus, and you're going to have 6 SO2s. On the bottom, you're going to have 3 times 2 is 6 S's, and they're going to be able to cancel. You see that? You're going to end up 3 times 3, 9 9O2s, which are not going to cancel. This is something I didn't foresee. Maybe I needed to multiply it times 2, not times 3. Hold on. All right. But I do have the 2s. So we do need that. And we need to change that. Let's see here. The 2s's cancel. The O2s is only on one side. So we need to be able to cancel. Oh no, actually that is good because we end up with 6 here and 3 down there. So we actually end up with only 3 and they're on the other side. So that's wrong. That's wrong. No, yeah, because this is 9. Yeah, that's correct. Okay, so 3 O2s there and S2 there, SO2 there. This is going to be 6S also, right? We did that. Okay, so the bottom is going to be, let's just erase that part. And instead of multiplying it, just multiply it directly. Okay, so this is going to be 6, because otherwise it's going to be a big mess. We're not going to be able to know what we're writing. All right, 6, and that's going to be 9, right? And that's going to be 2. So we got the 2 with that one. We said we were going to multiply it times 3, so that should be 6 there too. All right, so this should be 6 right there. Okay. Yeah, because we multiplied it times 3. Yeah. Okay, so this is times 3. This one's times 6. And that gives us 6 SO2. And I might as well just do it right there because it gets confusing like this. And it's best to have it done the right way. Okay. So since we're multiplying it times 6 and reversing it, we're going to end up with 6 SO2, 6 S's, and 6 over 1/2. No, sorry, 6 times 2 is 6 O2s, right? And that looks crazy. And this was a 9 right here. Sorry about that. All right, so let's see. So see, 3 times 2 is 6. That's 9. That's 6. That's 6. And that is 6. Those go away. That is 6 SO2s. Yeah, because that one doesn't have any. Okay. Yep. Okay. So that's how it's going to end up. Watch. This is how it's going to work. We're going to have 6 SO2s. The 6S is going to go away, like I said. This one, there's only 3 remaining on this side, right? And this one is not going to go away because they're different. So you're going to end up, this reaction, the coefficients, or you cannot erase it, but the coefficients are going to be 6 SO2 and then 3 here. And that should be balanced, but it's not. No, it's not. And this is what I'm telling you. Sometimes these things are weird and you've got to just keep on at it. I think 2 and 2 would have been better myself. But then that would not work. 3 on the top, maybe? 3 2s, no, no. See, they have to be able to cancel. So when I looked at that reaction, that with the 2s, I said that upper one has to be, 2s also. But you have to clear, hold on. Let me just do a math thing because it's just not working like this in my head. It's a little different than you having to do it on paper. I usually, when I'm on paper, I can do it really fast. But like this on the screen, it's just, my concept's wrong. All right, we reverse this one. We know that. So that we have to rewrite. So let's rewrite that again. All right, so rewriting this one, the SO2 has to come first, and then S plus O2. If you guys have any suggestions, do please tell me. See, to me, all you had to do was multiply the top one. All right, by 3. If you did that, then everything would be fine. But then you have, oh, I put 2s. I'd put 3s and it's really 2. Sorry about that. That should have been a 2. Was hoping. Okay, so if you multiply the top one by 2, which is what I've been saying, you would have one oxygen left, which is okay, isn't it? Okay, let's do that. That's probably what it was. Yeah, you don't need to do anything except multiply the top one times 2, right? Which gives you, sorry, I was going to say 2, but let's just do this. Let's just do this times 2, right? And then this one doesn't get anything. All right, so that would give us 2 SO2s. And sorry, I'm sitting here thinking through it. So 2 SO2s, that would give us 2 of each, right? All right, and that's what we wanted because we want to be able to cancel out the S's, right? Because they're not up there, as you can see. So that's how we take the clues from that. We want to be able to cancel these out. And this one only ends up with 1 oxygen. See that? That makes sense. That is correct, I believe. Let's see. So you got 2, oops, come on, draw. 2 SO2s, 2 SO3s, and 1 oxygen, right? That makes sense. Okay, so now we know that when we multiply this one and we reverse it, so that is going to be negative, so it's going to be 297 times 2. On, clear, come on. 297 times 2, that's going to give us 594 kilojoules. And adding these two together, so it's negative 72, so you say plus negative 792, right? That gives us exactly, okay, negative, nope, 198. See, something's wrong. Still something wrong, which is what I don't like. But this is balanced. No, it's not. It's 6 of them. So how do we end up with 3 oxygens on this side? By having 3 oxygens on the other side. But there's no way. This is why I multiplied the bottom one times 3. And I was like, no, that's not how it should be. The top one times 3. Try that. No, because then the oxygens would cancel and the S's would not. So ladies, you tell me what you think you should do. Because when I did this math, I got negative 198, which is half. So that means one of those needs to be multiplied by more than 2, right? So it must be 4. I don't get it. Why is it 4? It doesn't make sense that it's 4. Because then you get too many of these. All right, let me clear that again. Not everything though. I don't want to clear everything. Clear this for sure. Okay. So we had said 2 for this one, but what if we do 4 on this one? Then you have to do 2 on the bottom one. And that defeats the purpose again. I don't like this. No, because 4 on the top is going to give you 8. It's okay if you have oxygen left over, but what you don't want to have left over is sulfur, because it has to go away. So see, if we multiply 1 by 4 and the other one by 2, it's the same as saying 2 and nothing, which is what I did from the beginning. But it's not jiving because of that 2. SO2. Okay. So if we multiply this times 2 and reverse it, that's not going to give us enough. Nope. I get negative. What do you guys get? Do it on paper. That's what I'm going to do. It is very annoying for me to be able to not do it like this. I have to write in paper. This is more complicated for me doing it this way. I'm so used to doing these on paper, and I do, or on the board, which I can erase and go back and forth and stuff. But this right here is annoying to me. Hold on. I'm gonna come up with my own answer here in a minute. Okay. So maybe we need to divide. You know, that didn't occur to me. That didn't occur to me, but guess what? Maybe we just need to divide the bottom one by half. Yes, that is exactly right. Duh. Okay. Okay, so we're multiplying. So like dividing, same thing. This one, okay, so we're multiplying this. Oh, here we go. We don't reverse it. We multiply this one by 1/2, and we just reverse this one. So this becomes 297. That's what we're doing. See, I told you if I have paper and pen, I can see it immediately, but like this is just annoying to me. All right, so we're multiplying this one times half. So that's going to end up being clear. Here we go. This one's going to end up being S. Since it says 2, right? It's going to be S, and this one's also going to be, but this is going to be 3/2. Okay, so this is going to be 3/2 of O2. And there you go. And that's exactly right. Now it's balanced. Yep. Okay. So now what we did to the bottom one, so we multiply it by 1/2, but we didn't reverse it, right? So when we do that, we get -7, no, not point, -792 divided by 2 plus, and that's correct, 297. And that gives us exactly the number 99. Okay. Sorry about that. I had to see if I write it on paper, which is what I was telling you over here. I'm not used to looking at it like this. If I had a board, like if I had this reaction on a board that I could actually look at and it's not confusing like this, I would have done it in a second. But that's what it is. Yes. So once you multiply this one times half, right, that becomes half of that, which is I said the number, but now I don't have it divided by 2. It's -396. All right, now if you add those two, that gives you -99 kilojoules, which is correct. And looking at it, you'll see you get rid of the S's, right? And that's where I went wrong. And then you get rid of more of these. You get rid of both of these, but you only keep 1/2 of that. And there you go. And there it is, the answer right there, exactly like it was. See? So it would be SO2, right? That goes, oops. Let me have the 2 back. I meant to do this. SO2 goes here. 1/2 O2 goes there. SO3 goes there. You see? And there you go. That is correct. All right. Let's clear that. I know I got you guys mixed up, and I'm sorry. I'll do it on paper first next time. All right, so the next one, we're gonna do more. We have one more. All right, so remember that when we use energy to do work, we degrade its usefulness. What does that mean? That means it is degraded, means it is just going into a more spread out form, right? Because since the constant energy of the whole universe, the energy of the whole universe is a constant, you cannot lose it. So degrading doesn't mean leaving it, completely. What it means, it's spread out. It's like not concentrated anymore. Like the burning of petroleum. You are burning petroleum, right? And you get all that energy right there. But as you're burning it, you're spreading out that energy that is no longer in that petroleum because you're burning it, so you're using it, but you're transferring it to something else, which is much more wide. Does that make sense? Okay. Right, so let's do another one. And we're going to look at that later, but we're going to do another few of this Hess's law. And I am definitely going to go to a board with you. And I'm going to let you guys work on it. But let me reshare. Share. No, so we're going to share the board. And I'm going to write them in for you. Okay, so let me get some examples that we're going to use. Law. Oops. Something is in my, oh, it's my calculator. Okay. Here we go. Hess's law. Remember that. That's what we're doing. So it's energy right now. All about energy. So Hess's law is this. All right, okay, here we go. I'm going to give you one and you're going to manipulate it until you get it correct. And then you're going to tell me what the answer is. All right, remember, you have to start with the bottom, and that's where I screwed up. I started not with the bottom. And I don't like half, and that might be another reason. But they did have a half, and half is not really a good coefficient to have. So I would have multiplied everything times 2, but that's me. All right, so here goes. The reaction that you're going to want to end up with is 2, ooh, white, green. Let me clear that. I don't like that. Okay, let me do it in blue so we can see it better. Okay, so it's going to be 2C2 H5 COOH. That is a carboxylic acid. Oh no, not OOH, sorry. Nope, clear. Nope. No, that's not a carboxylic acid. This is an alcohol, COH. Nope, no COH. Not an aldehyde either, sorry, wrong. I have to look at my thing and write at the same time, so excuse me. All right, OH, that's what it is, OH. That's what we're gonna end up with. And that's a liquid, and that's on there. Plus O2 gas it's going to yield 2 C2H4O gas. And there's a plus on this one. I just didn't make it. Plus H2O. And it is how many H2Os? 2. 2 H2Os liquid. Okay. Now, the partial reactions, the two reactions that yield to this reaction are these. 2 C2H4O. And you can imagine that's a gas, but I'm going to do it anyway. Yields plus 5O2, sorry, plus 5O2 yields 4 CO2 plus 4 H2Os. And that's gas and liquid. If I start writing all of this gas and liquid, I'm not even gonna have a place to put the Hess's law. All right, so that first one, this delta H, and I'm gonna have to put it on the bottom here, is negative 2385 kilojoules. It's harder to write with your finger than you can imagine. All right, the next one, this is your reaction 1, and this is your second one, is C2H5OH, and I'm not gonna put liquid gas or anything like that, plus 3O2, which is going to yield 2 CO2 plus H2O. How many H2Os? 3 H2Os. Okay. And that reaction, the delta H is negative 1367 kilojoules. Okay, negative 1367 kilojoules. Okay, so I'm gonna do my thing on my paper and you guys do that one yourselves. All right, so remember, look at the top reaction and try to imitate what it's doing and get the answers from that. So you have to manipulate the bottom two reactions so that they look, when you add them together, like the top reaction, right? Right, and we don't know the delta H for that one. So we're calculating the delta H for the actual reaction on top. And this delta H is negative 283, 2385, sorry, 2385. And the second one, that's reaction A, reaction B, you can call them if you want. And C2H5OH, sorry, plus O2, that's just 3 O2s. Did I put the 3? Yeah. 2 CO2s plus 3 H2Os. Okay. And that delta H is equal to negative 1367. Okay. I obviously have to reverse that top one. That's all. I got it. Yep. Okay, so A should be CO2 plus H2O yields 2C2H4O plus 5H. So that delta H just became positive. Okay. B is now going to be double. Six H2O. Okay. Yep, that's correct. All right, so let's add them together. The 4 CO2 goes away. This one becomes a 2 here. This one becomes a 1 there. Okay. Add you together, you get two H2O. Yep, that is it. Okay. So bottom delta H now is 4. I think that's right. Okay, but we didn't reverse that. No. So 1367 times 2. Yep. Okay, let's add them up. Okay. That's what I got. All right, let's see if you get it. Yes, good. I haven't lost my touch. Just have to do it on paper. Sorry about that. It's just all there is to it. I have to use paper. Okay. You guys let me know what your delta H come out to be. Oh, excuse me, for the top reaction, which is the one we want to do. It's this weather changing all the time. Okay, for this reaction, for that reaction, you need to figure it out. We can go look at a few more if you want, because this is not an easy thing, I know. There's only one example on here. And we're also going to do a mole thing, which we're going to use that same equation that's up there. Well, a similar one. No, that is it. The same exact equation. And we're gonna figure that one out too. Okay. But first, let's do the delta H. The delta H for, oh, excuse me. I don't know what it is I got done. Got the wings done. Yeah. I would have written it with the computer, but I can't do subscripts on this one, so I can't really write it like it's supposed to be written, and I hate it when it's not subscripted. Okay, so anybody have an idea what to do for the first step? You can just chat it through. You can talk about it, whatever. I just need to know if you have any idea what to do on the first one. Remember, you have to compare the top reactions to the two bottom reactions and figure out what you need to do to get to that reaction that on top. So this reaction right here, right? This is the target. And we need to figure this out. So that's your target reaction. So just compare it to the bottom two reactions and see if something needs to be moved. If it does, then chances are you need to reverse it, right? And if you reverse it, don't forget to change the sign. And when you do that, also figure out, excuse me, also figure out if you need to multiply it by something. Because if you do, then chances are you are, you know, going to have to multiply one of the two because I don't see the numbers matching. And they don't, like both the two that have CO2s, one's a 4, one's a 2. So that's one way of looking at it after you compare it to the top, which the CO2s are gone. You see that? So you've got to balance those two. So that's my hint to you. That's what I failed to do on the last one. I needed to look at what was gone and then make sure that those two were even. And that's where I screwed up. Okay, so these two. Okay, what do you see? You see that? So what would you need to do to the bottom one to make it look like the top one? That's the hint, right? And also it needs to be on the other side of the equation so they can cancel. So that's the other thing. And see, you can see that the C2H4O is on this side, but the other one is on this side. So you need to reverse that, right? Okay. So let's, I don't know if you rewrote everything already, but just by looking at that, you can pretty much see that you need to reverse this one, right? So that means that that's going to give you a positive. And this one you need to multiply times 2, right? So that gives you times 2. And then you add the 2 together, and that's your answer. And that was a negative already, isn't it? Oh, did I not put negative on there? Oh, shoot. I'm sorry. That was supposed to be negative. Oh, it is there. It's just up on the top. So it's weird to look at it like that. Yeah, it's negative 1367. So if you multiply that times 2, right? Since you guys aren't talking, 2 times 1367, right? If you did it like this, then you did it right. It's negative, I forgot to put the negative, 1367 times 2. That gives me negative 2734, right? And then we add it to the one that we just reversed, and that is 2385. And the answer is negative. If you got that, then you did great. If not yet, we're going to do a few more. Negative 349 kilojoules. Okay, Jace. Oops. Let me make this bigger. There we go. So I can actually write on here. KJs, right? All right. So that's it. That's the whole thing. That's how you did it. Now, if you were to actually rewrite the ones that we did, like the reversed one, and then the one that we multiplied, it's easy. So let's just rewrite those. I'm going to rewrite them, and that means I'm going to erase this whole thing right here. including the Hess's law thing. Okay, we're just going to rewrite this whole thing. The other one we don't need to rewrite, but this one we do. Okay, so when we rewrite it, it's going to be reversed. And we're going to have to rewrite it by doing, where's my paper? Okay, here we go. We're going to rewrite it by making, yeah, here we go. It's going to be 2, because that's how it was written, right? Sorry, 4. That's how it was written originally. I've got the wrong one. Okay, so 4. Ooh, no, I don't want this big thing. Ooh, no, that's not clear. Let's see, just erase. That's all I want. Okay, draw. Give me the skinny. All right, 4 CO2s, right? We knew that. That was already there. Plus 4 H2Os. That was already there. But it was on the other side. Yields 2 C2H4O plus, and the one that was already here was 5 O2. So, okay. All right, so now let's look at it. All right, you notice that we multiply, we need to still multiply this one times 2. So that's going to be a 2 there. That's going to be a 6, right? Come on. That's going to be a 4. And that's going to be a 6. Oops, no stamp. I want this. And that, oh, come on, eraser. And then draw. That's going to be a 6. There we go. All right, now let's look. The 4 CO2 goes away. You see that? The 6 O2, this goes away. But this one you keep 1. Because it's like you're subtracting. So you keep 1 of these. Just 1, right? Then you've got 4 waters, right? So these waters on this side go away. But here, you only keep 2. Now, if you were to rewrite it, which you can, you don't have to, but you can look at it and you can see there's the 25H50C. There it is, check, right? There's the 102, check. On the other side, there's the 2 of these, right? Check. And then there's the 2 waters. You see that? Check. So there you go. So you know that you've got it right. So what you did to that first one is you reversed it. So that became a delta H of positive 2385. And you know, it's kilojoules. I just don't have enough room. And then the bottom one, we multiply it times 2, right? But we kept the direction, right? So that means that, Lord, that delta H was equal to 23 negative 2734, sorry, 2734 negative. When you add these two together, right, these two, this one and this one, you get negative 349, and that is the answer. Okay, you see that? Did you guys get that? If you did, good. If not, we're gonna do more. So let's clear these and we're gonna go look for some more problems. I'm gonna stop this share and do a new share. Back to the screen. so we can go look for some Hess's problems. All right, so we're going to click here and we're going to go on this one. Boom. And we're going to look for Hess's law problems or Hess's law worksheet. Practice problems. Here we go. All right, let's see. Using three equations and their enthalpies. Okay, there we go. All right, but these are already made. No, they're not. They're not. There we go. Well, they are, but what I'm going to do is I'm going to copy this whole thing. Okay. And I'm going to put it onto the board so we can do that. Yeah, go ahead, Corey. Yes, good. Good, Christina. You had gotten it. Good. Maybe we can get, you know, the answer is right here, but we don't want to look at the answer. Don't close your eyes. And let me just put it on, I guess we could put it on a sheet of paper too, because I can write on a sheet of paper just as easily as I can write on the board. Probably easier. Let's do a blank document and let me just paste these. All right, there we go. And look, they came out beautifully. All right, so let's do this one. Let's do it together. So I have never done this one either. So we're going to see if we can get this answer. This is 3 of them. So you have to pay attention. You have never done one with 3. So you have to pay attention, and let me make it bigger for you so you can see it and bring it down. Okay, there we go. Can you see it better now, or do you want me to make it even bigger? Maybe there. Okay, there we go. Okay, so this is the equation, the target equation on top. So you have to look at what's there and how we get rid of it, right? If we need to get rid of it, I mean. Yeah, I see it already. Yep, one of them's reversed for sure. Okay, so we can call him delta. You can call him ABC. Okay, let's do that. Let's give it a name. Well, it's not letting me type it. Nope, it's not letting me type it. Okay, why not? Why don't you let me type? Yeah, there we go. This is A, right? This is gonna be B. Come on, let me type it. Come on, you. This thing is annoying sometimes. No, see, it's the way that they did it themselves. And then this is C. Come on, let me type it. Come on. Oh, there we go. And C. That way you'll know what to do to A, to B, and to C. You know, delta HA, delta HB, delta HC. And that way you won't get confused. All right, so the first one. Okay, the bottom one. And you might want to write down what you did to this reaction on the side, just so that you don't forget what you did to it. And then there's no switches to change. What? Oh yeah, there it is. Okay, never mind. Yep, okay. And then the last one, H2. There's no H, yeah, there's H2. Okay, so that one looks like it's normal. Yep, looks like that one's okay. All righty, we got it. Okay. Okay, so reverse the first one. That's times. And the bottom one. Okay. Let me make sure that is correct. Okay, now this one keeps 4. So 2. All right, so this is, yep, that's it. Oh, wait, 2.5. Oh, 2 go to 2. Oh yeah, look at that. That's so cool. Okay. That is right. Okay, so I got it. Okay, I got my answer. I hope you guys are getting there. If not yet, you should be soon, right? Let's see if you got it. Gotta check and see what's up there, and that's how you do it. You gotta look at the top one and then manipulate the bottom ones, A, B, and C, to fit that. It's not letting me type anything before that. Let me just do it on this side. Yeah, there we go. You think that's gonna give you what, 10 minutes more or something like that, and you got it? I'm gonna give you just a few minutes. More, I mean, I can give you the whole class period, but just a few more minutes. And this is the last one. So if you can solve this one, you can leave. I'm just kidding. Okay. You got till 4:25. Okay. To do that, to finish. So that is 2 more minutes. According to my watch. Two more minutes. Like 1 more minute. Yep, 1 more minute. Gonna be able to do these. You have to be able to do them on demand too. So 1 more minute. One more. Less than a minute. About 30 seconds. We'll see. All right, somebody's got an answer. Yes, almost. But yes, I think you forgot that it's 0.8 instead of 0.7. But this one is 0.8, right? So it ended up being 0.7. At least on mine, that's what it did. But because you have a 0.5 on the top. Yes, that is correct. Yeah. Very good, Christina. All right, so let's see. What did you do to the first reaction? Oh, let me turn the other side. What did you do to the first reaction? Was there anything needed to be done? Yes, you reverse. So if you reverse it, oops, it's not letting me put it where I want to put it. Sorry. I don't know why it's not letting me put it where I want to put it. I want to put it right after this and it won't let me. See? Okay. Let me see. I think I know what it is. It's the stupid thing that I always do. Yeah, sure enough. It's that. Since it is okay, I'm just gonna put it on the bottom. Okay, so delta HA, we're gonna call it that. Delta, I don't have delta, but okay, let's insert a weird thing called delta. Equation symbols, here we go. We want a delta. There's more symbols somewhere in here. Where are you, delta? Do you see a delta? There's gotta be one in here somewhere. Come on, delta. Darn it. It's gotta be up there. Not like it's not crazy. No, it's not up there. All right, so delta, where are you, delta? Ah, we're getting close. Ah, here we go, delta. Insert, okay, we got it. Close that. All right, so we're gonna insert a delta. Delta H, we're just gonna call it delta HA, right? What we did is we reversed it. So since we reversed it, that means the is equal to, oh, sorry. You know what, I should have said reverse delta HA. I'm backwards today. Okay, so say reverse delta HA, right? Which means we now have a positive. So it's 1299.5 kilojoules, which is correct. All right, what did we do to the second one? Did we do anything to the second one? Okay, so we're going to say 2 times delta, and I need a delta in here. So insert, and since I just inserted it, it's probably going to be right there. Oh, come on, insert symbol. Delta, there it is. Delta HB, right? So now that delta HB is going to be equal to 787, but negative because it was negative. We didn't have to reverse that one, right? And that's kilojoules. Oops, wrong way. Kilo. Lord, kilojoules. There we go. And did we do anything to the third one? Okay, so no change. Oops, so I'll just call it, where's my capital lock? No change to delta HC, okay, which ended up being the same, which is negative 285.8 kilojoules. Now, when we add all these, right, so we need to now add all of these, add all delta H's. Oh, I'm just going to call it H's. One time I've looked for the delta, it's going to take, okay. So that's going to be equal to, so you're going to have 1299.5 plus, oops, plus, remember, you have to add them, even though they're negative, you have to add it. That's the idea. Negative 787, and we're just not putting the kilojoules, which is bad, but it takes longer. And then we're going to have a negative 285.8, right? And that's going to equal to the number, which the number that I got was 267.7 kilojoules. All right, and that's it. That is correct. See, so you've got to take the clues from the, do you want to do another one or are you just good enough? I know it's kind of getting late, so if you want to do another one, good. If not, we'll stop here. I'll go get a second one if you want to do a second one. Yeah or nay? Just thumbs up or thumbs down. Thumbs down. That's all I need. Okay, you think you got it? All right, good. All right, then everybody else got it? Thumbs up, thumbs down. I want to see. A thumbs up if you got it, a thumbs down if you need more. How do you do that? There you go. There's one. Okay, so you got it, Charity. Good. I'm glad. Jemiah, what about you? Okay. No answer. Okay. Well, we are going to have a few problems just like these. coming up. Okay, so I need for you guys to know how to do these, right? And this is it. We are done for the day, and you ladies have a wonderful, wonderful weekend. And I will see you in person Tuesday. All right, take care. And that'll be Hess's law. All right, let's type them in. This is gonna be a pain in the ass, it says. Wish I could take a picture of these and just put them up there. You know, I should. It's a pain in the behind. Oops. I know. I said no, but I'm almost there. I'm gonna have to pee too. I have to save it because I don't want anything to be wrong with it by the time I get back, you know? Okay. I did that. Now I gotta pee. Okay. Once I pee, then maybe. Oh, and I gotta get my glasses too. My glasses, otherwise you can't drive. I'm gonna pee first. Then we go. All right.